Hello, beautiful people. Today we're going to be talking about the Pythagorean theorem, and our swab at is going to be apply the Pythagorean theorem and its converse. So some vocabulary for you. The hypotenuse of a right triangle is the side opposite of the right angle. So the hypotenuse is going to be this one right here. It didn't say it on here, but this would be your right angle because that's what's formed by the two different legs. The legs here form the right triangle. And then opposite of it, so one way to remember is that it will always point to the hypotenuse. That right angle will always point to the hypotenuse, and it's always going to be your longest leg. I'm sorry, your longest length. Longest length. Practice that. Next thing I want you to know is the Pythagorean theorem. We will only be able to use this if it's a right triangle. So if it is a triangle that is right, then the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Sounds risky, but it's really not. So if these two are the legs, then the Pythagorean theorem says that a squared plus b squared equals c squared. The legs squared added together is equal to the hypotenuse every single time. A squared plus b squared equals c squared. The only thing that's difficult about this is identifying the A and B. And so if you can see where the right triangle is, or where the right angle is, you'll be able to see what the legs are. You're always going to add these two their squares together, and that will always give you the C. Okay, so let A and B represent the lengths of the legs of a right triangle. So you have a right triangle in your head. Here's your A, here's your B, and here's your C. Let C represent the hypotenuse. So that's it pointing to the right angle. Is right there. For number 1, they are telling you that B is equal to 3 and C is equal to 7. They would like for us to find the missing length. Find the missing length. So for this one, we're looking for the A. Well, we know the Pythagorean theorem says A squared plus B squared is equal to C squared. So for this equation, we don't know what the A is, so I'm just going to leave it as A squared plus, instead of B squared, B is given as 3. So 3 squared equals C squared, 7 squared. Now let's simplify and solve. 3 squared is 9 equals 7 squared is 49. So to solve this now, I'm going to subtract 9 on both sides, and I get A squared is equal to 40. I will now square root both sides, and A is equal to, the square root of 40, if you enter it into your calculator, is 6.32. Round it to the nearest hundredth. I just want 2 numbers after the decimal point. Notice here, though, I didn't write a plus or minus on this one. The reason why is because I can't have a negative length. So for your next one, I have B equals 5 and C equals 10. If I'm trying to find the missing length, that means I'm trying to find the A again. If you'd like to, you can go ahead and press pause and try this one on your own. Otherwise, you can stay with me. I'm going to plug in kind of the same way I just did for the last example. And I have A squared plus 25 equals 100. Subtracting 25 on both sides. I have A squared is equal to 75. Not really looking for A squared, I'm looking for A. So I take the square root and I get A is equal to 8.66. Okay, let's try one more together. So A squared is given this time as 5 plus 12 squared equals C squared. 5 squared is 25 plus 144 equals C squared. 25 plus 144 is 169, if you can trust my math. And then I'll square root both sides. C is equal to 13. There you go. Okay, now this is where the converse part of this comes into for our swab at for the day. So now it's saying tell whether the triangle with the given side lengths is a right triangle. So if it is a right triangle, then A squared plus B squared equals C squared. In these examples, they're giving me an A, B, and C, and they're asking me, does it make a right triangle? Does it fit the Pythagorean theorem? So first thing you have to do is determine which one's A, which one's B, and which one's C. Now between A and B, no one really cares. But the main thing is identifying that this is C. How do I know that that's C? Because it's last and it goes A, B, and C? Not so much. Mathematically, I know it because it's the longest length. C is always the longest length, so it's always going to be your biggest number. Okay, so let's check it and see. So I'll make this A and this B. No one cares again, though, if you switch the A and B, as long as you see that C will be your longest one. So 9 squared plus 12 squared. We're checking to see, does that equal to 15 squared? Well, 9 squared is 81, and you can't add those until you have done your exponents first. Plus 144 equals 15 squared is 225. Now adding 81 plus 144, I get 225 equals 225. Ding, ding, ding. Yes, it is a right triangle. Yay. For the next one, same thing. A, B. This one is C because it's the longest side. So it is 9 squared plus 21 squared equal to 24 squared. Well, 9 squared we know is 81. 21 squared, if you use your calculator, is 441. Does that equal to 576? I don't know. Well, let's check. 81 plus 441, doesn't look like it does, is 522. That is not the same as 576. Therefore, this is not a right triangle. If it's not a right triangle, can you say that it's a wrong triangle? Yeah, sorry. I really thought that was funny in my head. But no, it's not. It's not a right triangle. Moving on. Okay, last example for you, and then you're done with your notes. A teacher is cutting along the diagonal of a rectangular piece of construction paper. So here's my construction paper. I'll be the teacher. And it says that I am cutting along the diagonal. This is all for my bulletin board, which is 11 inches long. So 11 inches long. And it says that it is 8 inches wide. No one cares if you switch these two. The only reason why I made this 11 and this one 8, this 11 and this one 8, is because it looked like it was shorter in my drawing that I just made. And also note, it's not 8 inches, it's actually 8.5 inches. So go ahead and fix that. Sorry. So the question is, what will the length of the cut be? So how long am I cutting? How long is this? Looks like a right triangle because it is a piece of construction paper. So your A for this one could be 8.5. Your B would have to be your 11 inches. And your C, that diagonal, that's the question mark. That's what we're trying to find. So let's find that by using our Pythagorean theorem. So it'll be 8.5 squared plus 11 squared equals C squared. We don't know what C is, so I'm just going to put the variable. 8.5 squared is 72.25 plus 11 squared, that's 121, equals C squared. Adding these two together, I get 193.25 equals C squared. Now that C is by itself and everything is simplified on the left side, I'm going to square root both sides, and I get 13.9 roughly inches. That's how long the diagonal is. I could put it in my diagram if I wanted to. 13.9 inches. Okay, that's your introduction to the Pythagorean theorem. Thank you very much.